Welcome to all of you. In this lecture, we are going to have a continuation of linear convolution in time domain. So just a recall of the time domain formula for linear convolution, that is y of m is equal to summation n is equal to minus infinity to plus infinity x of n h of m minus n for all the values of m ranging from minus infinity to the plus infinity. So this is once again a recall of the various steps involved in solving linear convolution in time domain. Let us go through one more problem on linear convolution where in the given sequence the first element itself is not the origin. Let us go through the problem statement. Find the linear convolution of the sequence x of n is equal to 1, 2 and the system having the impulse response h of n is equal to 3, 4, 5. Let us go through the solution. So given the sequence x of n and h of n, let us identify the length of each of the sequences. Length of x of n is equal to 2. So there are two values present, therefore length of x of n is 2. Similarly, length of h of n is 3. Total 3 elements are there, therefore length of h of n is equal to 3. So before getting into the various steps, let us first identify few things with respect to the x of n and h of n. So in the x of n we are having two values and we need to identify that the first element itself is not the origin in x of n. This second element is what the origin, that is indicated by this arrow mark. Then this position will become 0. The position of the value 2 is 0 and this 1 is present before this origin. Therefore, position of this value will become minus 1. Similarly, in case of h of n, first element is not the origin. This is going to be the origin. The value 4 is the origin. Therefore, the value 3 is going to be at the location minus 1 because it is before this origin value. Therefore, the location of 3 is minus 1 and the value 5 is on the right side of the origin. Therefore, the location of 5 is 1. So position wise if I speak, so this is position minus 1, 0 and plus 1. So this is the important thing with respect to linear convolution. So that's why mentioning the origin in linear convolution is must and should. Now let us go through the various steps of the solution. Step 1. Calculate the output sequence length given by capital letter N, that is equal to length of x of n plus length of h of n minus 1, that is equal to, so 2 plus 3 minus 1, that is equal to 4. So output sequence must have the length 4. Step 2. Identify the starting index of x of n and starting index of h of n. So what is the meaning of starting index? Position of the very first element present in x of n and h of n is what the starting index. So with respect to x of n, starting index stands with the position of this value 1. So position of this value is minus 1. The position is minus 1. Therefore, with respect to x of n, the position of the very first element in x of n is minus 1. Therefore, x underscore si is equal to minus 1. Similarly, with respect to h of n, the position of the first element in h of n, that is the position of the value 3 is once again minus 1. Therefore, h underscore si is going to be minus 1. Identify the ending index of x of n and ending index of h of n. That means position of the last element in each of these sequences I have to identify. So with respect to x of n, the last element itself is the 2 and 2 itself is the origin. Therefore, the position of the last element stands with the value 0. Then what about h of n? In h of n, the position of the last element is plus 1. So this is origin, position 0, then this is position 1. Therefore, the position of the last element in h of n is 1. Therefore, h underscore ei is equal to 1. Step 4. Identify the lower limit of the summation given by x underscore si plus h underscore si. This we have calculated previously. Substitute it, we get as minus 2. Step 5. Identify the upper limit of the summation given by x underscore ei plus h underscore ei. We are going to get the value as 1. So that means for all the values of m ranging between minus 2 to 1, we need to calculate the y of m. Also, the summation will take the range from minus 2 to 1. So, the last step, calculate the output sequence y of m for each value ranging from m ranging from minus 2 up to 1. And same will be the summation range also. Therefore, the formula of the linear convolution now takes the form y of m is equal to summation minus 2 to 1 x of n h of m minus n for all the values of m ranging from minus 2 to 1. Now let us calculate at each value. So the very first value is at m is equal to minus 2. So this will become y of minus 2 is equal to summation minus 2 to 1 x of n h of minus 2 minus n. Now expand this summation, we are going to get this representation. Now resolving the values within this bracket with respect to h, we are going to get this representation. Now we are having y of minus 2 is equal to x of minus 2 into h of 0 plus x of minus 1 into h of minus 1 plus x of 0 h of minus 2 plus x of 1 h of minus 3. Now let us make a substitution for these values. So x of minus 2 with respect to x of n, the value at x of minus 2 is not at all present. Therefore, this value becomes equal to 0 even though h of 0 is having a value. So when this value is 0, obviously multiplication of these two will become 0. So 0 has been written over here. The next one, x of minus 1 into h of minus 1. So both of these two values are available for us. X of minus 1 is the value 1. H of minus 1 is the value 3. Therefore, 1 into 3 substituted. Further, x of 0 into h of minus 2. X of 0 is there, but h of minus 2 value is not there. Therefore, this value totally becomes 0. Then x of 1 into h of minus 3. Both of these two values are not available for us in the given sequence. Therefore, once again, this is going to be 0. Therefore, after simplification, we are going to get the answer as 3. Continuation with m is equal to minus 1. So, y of minus 1 is equal to summation n is equal to minus 2 to 1 x of n h of minus 1 minus n. By expanding and resolving, we are going to get the answer as 10. In continuation, at m is equal to 0, we are going to get the answer as 13. At m is equal to 1, we are going to get the answer as 10. So, as per the procedure, we need to calculate 4 values with respect to the output. That is, the output sequence length is equal to 4. Therefore, the range starting from minus 2 ending with 1 we have taken. So, that value we have calculated. Therefore, final y of m is represented by y of m is equal to 3, 10, 30 and 10. Again here we need to identify the origin. The origin is identified by using the formula x underscore si plus h underscore si. So both of these two values are known for us from previously. Therefore, x of x underscore si is minus 1, h underscore si is minus 1. So we have taken it as minus 2. So that means the position of very first element in y of m is equal to minus 2. Then which is the origin? Identify that. So this is minus 2 position, this is minus 1, this is 0. Therefore, this is going to be the position of the origin. That's why the arrow mark is given for the value 13, which is indicating this is the origin. See, procedurally in the time domain it remains the same, but based on the origin, from where to where we need to calculate, that means the range of the m as well as the range of the summation is going to vary. So we have to take care of that in case of linear convolution. Now since we have calculated, let us have a verification method which is very simple, and it is not going to consider the origin position into consideration. Now this is a very simple verification method, and this is just a verification method that we can make use of, but don't consider this as an actual method of calculation, right? So same values I'm going to take. So x of n, and this is the h of n value. So 1, 2, multiplication symbol, 3, 4, 5. So we are going to perform a regular multiplication. So that is, I'm taking 5. 5 into 2, it is 10. Then 5 into 1, it is 5. Then take 4. 4 into 2, it is 8. Then 4 into 1, it is 4. Then take 3. 3 into 2, it is 6. Then 3 into 1, it is 3. Now sum all these things. So this is 10. This is 5 plus 8, 13. 4 plus 6, it is 10. And 3 written as it is. Now with respect to previous time domain formula solution, we have got the answer that has been written over here. That is y of m is equal to 3, 10, 13, 10. And with this method also we are getting the same value, 3, 10, 13, 10. And here in this verification method I am not considering any origin or from to range. It is just a simple multiplication using which we can cross verify the answer of the linear convolution. Whatever may be the method we are following, that means time domain solution or circular convolution method for to calculate linear convolution, or the frequency domain solution we are making. So in any of these, the result we are going to get can be cross validated by this method. Thanks for joining.